Dennis Anderson, and this is a lecture regarding some topics that we need to talk about today. First of which being the beginning class level signal flow. And what we're going to do is talk about a project studio based on DigiDesign's Digi 2 or a Digi 3 if you can find one, and a Mac computer. So let's get started. The first thing we want to begin with is talking about the computer itself. The wiring there is pretty simple. We're talking about a computer that's going to a monitor and to a USB keyboard and mouse. But we have to remember that when we're working with Pro Tools, we need to be recording everything to an external hard drive. And for that external hard drive, if we're using a multi-track system like we are today, that has to be a FireWire. Now, there used to be an M-Box that DigiDesign put out. Now it's made by Avid. That would use a USB cable, but USB can only carry a couple of channels. When we're dealing with more than two, we want to be using FireWire. And if we use the Digi 2 or the Digi 3 interfaces, we also have to remember that that is FireWire 400. So we have to find cables and adapters that are going to give us that FireWire 400 signal. And then we'll be going along just fine. Now the Digi 2 or the Digi 3 are very similar. Digi 3 came out a few years after the Digi 2, but they both have essentially the same kind of functions and the same kinds of inputs and outputs. We have 4 balanced XLR microphone inputs, and in these 4 inputs, each one of those has its own gain control, and then they are paired up in number 1 and 2 with a phantom power button, so you can send phantom out 1 and 2 simultaneously, or 3 and 4 simultaneously. Now there are 4 balanced analog line inputs as well in this interface, so that so far gives us 8 analog inputs going into this interface made by DigiDesign and then later Avid. We also, in addition to analog inputs, have the capability of getting digital optical audio signals, 8 channels of that, what we refer to as the ADAT or the light pipe. That has an input and an output. It's always a circular motion with those digital those digital inputs and outputs. So we now have a total of 16 lines, 8 analog plus the 8 digital coming in. And there's another pair of digital signal inputs, and that is the SPDIF input. So we can now have a total of 18 lines going into this Digi 2 or the Digi 3 and then on into Pro Tools. The nice thing about these units is that they, of course, have their outputs as well. As I mentioned, there is the ADAT output, 8 channels of digital audio. If you have something that can take that, great. But you also have 8 analog balanced 1/4-inch line outputs. The main outputs for the monitoring are coming out number 1 and 2. And there is also an option of having alternate speakers connected to another pair of 1/4-inch balanced outputs. But the other 6 outputs, number 3 through 8, could be used, for instance, for, let's say, a 6-channel headphone amplifier, such that within Pro Tools you can designate which outputs you want to send signal to and create a very elaborate headphone mix for 6 people, so each person can have their own personal monitor mix. It's a very versatile device. The nicest part of all, and the reason I've selected this, they can be had out on eBay for as little as $400. They sold for $2,500 new. And they'll interface with anything that will take a 400 FireWire type of a cable, or that would adapt down to FireWire 400. So they're a great system to have and a great startup unit. There are also, as I mentioned, these inputs and outputs have, on our diagram that we're looking at, guitars and microphones for guitar, acoustic guitar, and a vocalist. The electric guitar and the electric bass guitar in your diagram that you're looking at are going through DI boxes, direct injection boxes. Now, the purpose of these is to convert the high impedance signal coming from an electric guitar or from an electric bass guitar down to a low impedance microphone level. The interesting thing about these DI boxes is that they have 3 ports. They have a 1/4" input, that's unbalanced, coming from your guitars. And they have, of course, the XLR balanced output, so that moves on as if it were a microphone signal at a low impedance. But then there's also a 1/4" high impedance output that could go over to an amplifier, such that the guitar thinks it's sending a signal to the amplifier, but it's not. It's going to the box. The console thinks it's getting a microphone because it's receiving this balanced signal that's been stepped down to low impedance by our DI box. And that amplifier thinks it's getting the guitar signal because it's coming from the box, literally passing through and continuing on. So we've simply tapped into that signal and converted it down so that we have low impedance signal coming in along with our microphone signals that are going to be amplified within our mixer or our digital interface like this Digi 2. Now, the signals that we have from the guitars are coming in as if they were microphones, but we have microphones going out there to an acoustic guitar and then a vocalist. Those microphones we could use either just a straightforward SM57 or an SM58, a dynamic microphone, or we could use condenser microphones and get a really good signal from that guitar. If it's a really nice guitar, we want a really nice microphone on that. Of course, we want a nice vocalist signal, so we would use condenser microphones, and there in the back of the Digi 2 is a button that sends that phantom power out to those condenser microphones, thereby powering those up, and now we've got a great signal from electric guitar, electric bass, acoustic guitar, and a vocalist, all coming in through our microphone lines. There is a MIDI capability with this device, and because of that we can have a MIDI keyboard playing into the MIDI in port, and then there are 2 MIDI out ports. So we could have, let's say, a drum module and another sort of sound module that can give us keyboards or strings, brass, something interesting. In Pro Tools, we can designate where we want to send our MIDI signal. So we send it out to these devices, and these devices, the drum machine or the sound module, have analog outputs coming out the back, so we bring that analog signal from those MIDI devices that are outboard, outside the box, back in and record them into Pro Tools as actual audio tracks. So our drum module, for instance, if that is on our MIDI out number 2, we'll bring that into the inputs number 7 and 8. And if our sound module is MIDI number 1, we'll bring that into the analog inputs number 5 and 6. And we can record, like I said, analog right in. The nice part is we can also record MIDI at the same time. So we can go and change those sounds that are in those devices. We've already got the MIDI tracks, and we can simply double up our sound. We can have an electric piano sound, back up, switch the sound module, add 2 new tracks that are clones of the inputs and outputs, and maybe switch to regular piano. So we can have a really nice rich sound very quickly and very simply. Therefore, we've got an 8-channel system that's capable of simply doubling up its tracks and giving us a really wonderful project with a very simple approach, using just analog signal in. We're not even using anything that's digital going back into the unit. We could say that for another day. Now, I want to move on to the advanced portion of this lecture. This is something that we would be dealing with as a final semester, and I would like to call this this concept we're talking about now a senior project. I think it's important, after students have gone through the whole process of learning how to do the engineering, they usually have a pretty good idea of what a good studio is like. So my project is design a studio from scratch. They can do whatever they want to do, shape it however they want to shape it, use whatever equipment they want to use under certain guidelines that I'd like to present right now as an example, okay, of a studio that they could use. So on the page that you have that says Advanced Lecture, this is it. Design a Pro Tools professional recording studio. It's going to have a large tracking room, it's going to have a control room, it'll have isolation rooms, and I would like to include a couple of my own innovation that I have found to be very successful, so I recommend including this. 2 separate guitar amplifier vaults. Okay, and these vaults are going to have certain characteristics that first of all keep them isolated away from everything else and make them very versatile and usable in all kinds of recording situations. Now, with our large tracking room, what we want to consider there is that we have a good hardwood floor and then good reverberation within that room so that it's not ugly or harsh, but that it's a pleasant sound. Okay? You can always put curtains and other kinds of sound surfaces on them, but you want to be able to get a nice good live sound from a room if you need it. Very useful. Our isolation rooms, they're going to be soundproof from everything else, but what we want to look at with the main tracking room is that we have at least 16 inputs in that room so that we can have a lot of things going on if we need to. So let's just figure we've got a wall panel that has 16 inputs there. Let's figure that in each of the other rooms, these isolation rooms, we have at least 2 inputs, and that includes those guitar amp vaults. Now, the reason we want 2 inputs, there are times when you have 2 people in a room, or you have a person who's singing along with an acoustic guitar, or even an electric guitar that you need to put a DI box on and run into a microphone input. So, minimum of 2 inputs in these isolation booths. We want to have one isolation booth that's large enough to fit an entire drum kit in for a small drum kit miking. So there we would have a minimum of 8 inputs. If we want to have more, and we have another way of miking up a drum kit where we're using 12 inputs, then it might be advisable to put the drummer out in the big tracking room and send everybody else into smaller rooms. But in that other booth, let's just call it the drum booth, we could use that, and in the diagram I'm providing in the possible project that we would want a studio like this for, a jazz rock group, we have a horn section, 8 people. So we want that room large enough to have 8 people at least sitting somewhat comfortably and being able to be goboed off a little bit with some sound baffles and acoustic treatment, and put 2 alto saxes, 2 tenor saxes, a couple of trumpets, and a couple of trombones in that room. There's 8 lines right there. And they're used to playing with each other, they like to hear each other, so that works out pretty nicely for them. Now, if we move on to the control room itself, there's a schematic diagram that I'm supplying with this lecture that accompanies this that's very elaborate, but really what it is a breakdown of everything involved with the control room in a Pro Tools HD studio. And that's a more elaborate system than your Digi 2 or the Digi 3. It involves more equipment, more interfaces. It involves special cards that have to be installed, PCE cards, into the computer. So I'm going to break down right now what all of that equipment is and a general approach to our microphone lines and our signal flow. Let's take this jazz rock project that we're going to do, and we've got the Control 24 console, which is an interface in its own way of breaking down the signal and transforming, a lot of the signal from microphone to line and line to microphone. And it's a communicator with the computer. In fact, a good way to put it is that the Control 24 control surface is really just a very expensive mouse. Everything that happens on the screen can be touched and manipulated on this Control 24. So it's nice if you're used to working with things that you touch and move. Now, you also need interfaces themselves. With this, we would supply into the studio a couple of their 192 I/O interfaces. And these again can be got out on eBay for a very inexpensive price, and they're wonderful. Okay, they work beautifully. There are levels of Pro Tools, versions of Pro Tools, that will not accommodate this older vintage equipment. So keep your wits about you. Get a Pro Tools system, and my advice is, if it's working, leave it working. Don't mess with it. Don't update it. So you want to find a couple of these interfaces. These interfaces can take up to 16 analog lines in, and they convert them over into a digital signal and send that over to the computer. Now, if we have 2 of these, that gives us 32 lines that we can work with. So if we're looking at our tracking room and our guitar booths and the isolation booths, let's count them up. 16 lines out in the tracking room. Okay, then we have 2 lines over in the vocal room, another couple of lines in each of those guitar boxes, so there's 2 lines per guitar amp vault. And those amp vaults, remember, they're closed up, they're a box, so there's a guitar input, actually 2 guitar inputs, on the outside of these boxes. They're no bigger than a refrigerator. They don't have to be. Just big enough to put an amplifier and microphones in. As we continue counting around, we get to a room where we can have a grand piano. 2 microphones required for any grand piano to get a good low end and a good high end. And then of course those 8 lines that we want to have for the people that are sitting in the booth, like our horn section. If we are using 12 microphone lines for the drums out in the big room. Now the bass player would be out there too, and the bass player would be plugged in direct. It's not a good idea to put an amplifier in a room with a bunch of other musicians if that amplifier is a bass amplifier, because those frequencies will get into everything everywhere. Now, as we look at the overall design of how this control room is set up, remember, we have the 16 lines that go into the Control 24, then lines 17 through 24 would be going into the first interface, and then, into the second interface, and then the next 8 lines are going to be going into that interface as well. But in order to get into that interface, remember, we have all microphones out there, and these interfaces only take line level. So in order to get into the interfaces, we insert into the studio flow, into the signal flow, a couple of 8-channel microphone preamps. And a very good one to use is made by True. It's called a Precision 8. You can put 8 microphone lines in, and it sends out 8 analog line levels out. So those line levels go into that interface, the B, interface B, the 192. And if you don't want to buy the extra card to make that a 16 input, you can get a converter that's simply going to change line level coming from that second True Precision 8 preamp. You can send line levels into another 8-channel preamp that's going to convert over an ADA converter into a digital signal, and use the use the ADAT signal to go into that second half of that interface B 192 I/O. Now, I've also included with this lecture some actual information regarding the miking placement of the drums. We will have probably covered this by the time we get to this point, but if we want to have a studio that's designed so that it can be a full-on professional studio, we have to take into account enough lines out there so that we can do a full drum miking. So there is a 2-page drum miking bit of information on how to mic up a drum kit with 8 mics, or how to mic it up with 12. The difference with the 12, we're adding 1 mic to the kick drum out further away, and we tent that off and close it in. We put another mic under the snare drum. Then we have 2 microphones out in the room. So that adds additional 4 microphones to our usual 8 mic setup. When the students design this studio, they also have to take into account the costs. So they need to come up with and research what the materials to build the studio itself are going to cost. They would probably want to look into some contractors that could actually do the work for them. And then they have to come up with the cost of the equipment, the software, and all of the wiring that goes to all of those different locations. The last part of all of this is the headphone system. A great system to use is made by the Hear company, and they have a system called Hear Back, where you take 8 lines analog coming into the back of this hub, and it sends out through Ethernet cables to 8 different locations where you can have a mixer and each person can dial in their own headphone mix. So you've got a very well-running and a very effective recording studio. This is the final senior project, and if the students can design this, they can go anywhere and do anything because they will be prepared to work in the real world of recording engineering.